slightly more difficult.
I understand. So let's look at this example here. What if I gave you this? Y equal to 2x and y equal to x cubed, let's say. I don't care. It doesn't really matter. It could be x squared, x cubed. And it could have been, I don't know, 2 sine x or something. Anyhow, just one of those things. So there's a curve intersecting a curve, or a line intersecting a curve. And I rotate it. Let's see, what am I going to do? I'm going to rotate it about the x-axis. Can you draw that picture for me, please?
You're going to rotate both of them?
Well, this is a bound region rotated about the x-axis. Or the y-axis, but let's do the x, because the y is just as fun. But it's the same process, it doesn't matter. And the x-axis is easier, because then I got this really cool little thing over here. Okay, so let's look at this. If I go to this, y equal to 2x over 2. I got that really cool little region right there, right?
Right.
And it's rotating about the x-axis, so then it also, this crazy thing is kind of, it's like down here as well, right? And then it's rotating, and I've got this crazy thing happening like this. And I've got all those little, no longer discs.
They're washers.
Right? They are no longer discs. Because there's a hole in the middle. I got this cool little solid part here and there's nothing there.
Oh, yeah, going the other part,
No, it's not.
We're just going.
We're not bounding it in zero.
Oh, we're rounding.
Where'd that come from?
Got it.
Feeling my ears. Anyways.
Isn't that funny? Do it again. Okay.
Anyways.
Okay. So what I have here, if I were to draw a picture, I'd have a picture of something like this.
Wait, so at the very center, isn't it solid there? I mean, not at the very center, at the tip, where the 0, point, isn't it solid?
Doesn't look like it to me. It's just a point.
But don't they?
I know it's just a point.
It's still a disc. A disc until then.
Oh, so it's a disc until then.
Sure. Well, it's a washer until then, but it's circular in motion until then. It's a point, still circular.
Yes,
I'm not struggling with consistency.
So the area is really quite simple then, because all I want is this. Area, integrate that, and I get a volume.
One's not.
That's the small radius of background.
Okay, the larger radius subtracting the smaller radius, right? So then going all the way from here to here, subtracting going from here to here. So the integral then would look something like this in this method. It'd be a to b, pi multiplied by some big R, say we'll call big R the longest radius, squared, minus little r, pi little r squared dx. Right?
Yep.
Yeah.
And
How did we find it? Big R again? Oh no, we look on that. I can't remember. 'Cause I did this.
take deep breath,
I'm trying to remember.
take deep breath.
I'm trying to remember.
Here we go. I need R's now. How do I find big R?
I don't know.
Big
That was
R
created by
is,
It's created by 2x. Right?
That makes sense.
So it just simply becomes, big R becomes 2x. Correct?
Yes.
Okay. Let me go ahead. So I got pi multiplied by 2x squared minus, okay. And then how do I find little r?
Is that x with x cubed?
That's just x cubed, right?
That's the line. That's like,
Oh, it's just
this is the line.
Squared dx.
Also,
Now,
That's the small radius.
Okay, so now, ladies and gentlemen, the issue maybe becomes the bounds. From where to where?
Isn't it from 0 to the intersection point?
From 0
Which
to,
is equally.
okay, and I do that, and I get,
Root 2?
Same.
you sure it's root 2?
Oh, I got what you said.
I'm just waiting for everybody to catch up, making sure they understood it was root 2. And I saw enough around the room, I think I was able to say we're there. Everybody understand why it's root 2, right?
Is that the
You
intersection?
said them to each other.
That's that intersection point.
And now, is that in? I just boom and I do that and I'm done, right? And you all know how to do this now, I hope. And this, I hope. And then evaluate them, I hope. So helping you set up the problem now, you can just do it. Is anybody taping this?
It's her birthday too.
Oh, happy birthday!
So we're not taking Pep's birthday, or?
Now, we've got this crazy thing, we're okay with this setup, right? Everybody understands that this, and that's called a washer. It's somebody looked that up yesterday in this class, was it this month? You understand why it's a washer now? Okay, now, all I gotta do is put just a little bit of a quirk in it, and it becomes really fun.
Why are discs? Why are discs and discs and not washers?
Or not.
Because there's no hole in it.
No, like a
No,
Like, I just,
like a
this is
CD.
I don't ask me.
Like
this
that
isn't
confused me
that.
so
Ask
much.
me if I
Setting it
care.
up, you know?
Do you care?
No, I really don't care why that's a chair, and then that's a stool, and they are the same nutty thing.
We were saying disc yesterday.
Same word as a battery.
I was thinking of washers with discs or disc for washers, because I was thinking disc. And then you said that, and then you blew my mind, you're like, that's a washer, I'm like, but that's a disc. I don't know, just couldn't even.
Moving right along. What if I took this same exact problem?
Over the y-axis.
No. The same exact problem,
And that's it.
and I rotated it about, oh, that's an O. I rotated it about, let's say x equal to 1.
Oh.
So I take the same exact picture, I've got this thing that looks like, that's kind of gross, looks like this.
Same, except you're bound to your
Well,
lower
but now
bound.
it's-
And
but now
now
it's
I'm
not
gonna
symmetrical,
rotate it
though.
about x equal to 1. Because remember, this was root 2,
Oh,
What's
that's
the
so-
one plus?
which is smaller than, was that smaller than 1?
No.
Root 2 is greater than
Oh, wait.
Yeah.
Oh, we can't do 1, we have to do 2 then. I gotta have something greater than root 2. Okay, so we're gonna rotate about 2.
And then two.
What do I have now?
Washer.
I have like a weird.
It's a,
Like a volcano.
well, it's a washer, but it's
So
a
one
weird.
is just around one either.
What's it weird?
It's
A
this,
normal,
isn't it?
a normal,
Oh, around that.
what is,
It's a volcano!
Yeah, it is.
With a hole, it's got a hole in it, because
I
it's a
feel like volcanoes
volcano.
tend to have those.
Okay.
It's a volcano with a hole in it.
Wow.
It's actually a frustrum with a hole in it, but we'll call it a volcano because it's more
Correct.
fun.
Frustrum.
Frustrum.
is that because you're gonna be frustrated at it when you're trying
You
to
might
solve
be.
it?
Anytime we take a cone or a pyramid and we chop off the top, we truncate it, it's called a frustrum.
So then a frustrum's any solid that,
It has the top cut off.
It's an English class.
Well,
Except for cylinder.
except for a cylinder, because that's still a cylinder. Or a cube, it's still a cube. Or a rectangular prism, it's still a rectangle. But if we take a cone or a pyramid or something that goes to a point, chop it off, now it's a frustrum.
okay,
Circular frustrum?
pyramidal.
Very good. Okay, so what would you do now? We have this issue going on now. How would I now generate the integral?
Is our
What's changed?
radius?
The radius!
Do we add one onto each?
No, it's not adding 1.
I mean,
Think logically for a minute. What is
fine.
the distance from here to here?
2 minus root 2.
Yeah, it's 2 minus 2x.
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 I went to the straight line. From here to here is
Oh.
2 minus x cubed. What's my r? That's the big R. That's the little r. I put them into the formula and I calculate it out.
It's that simple.
Of course it is.
Two minus.
minus 2x.
Of course. I got this one right here, right here. Isn't this 2x?
Yeah.
Oh, okay,
Isn't this
okay,
2?
Okay.
So the larger one is 2 minus 2x, the distance from here to here, that r, that
Okay.
length from there to there.
And so if it was at 3, it'd be 3 minus 2.
Fact. And this distance from here to here is 2 minus x cubed. So these now become my big R, my little r. I put it into that, and I'm done.
But your bounds are
Oh, what's my bounds?
Yeah.
So you still, okay.
0 to
Is it the same?
No,
Yeah,
maybe.
No, you have to.
Because you
0
still
plus
want
2 root
points that
2.
intersect.
Of course I want the point to intersect. Well, there it is.
what? So then what?
So it'd be 0 and.
Oh, they're the same bounds?
Ooh, are they?
Everything's- Yeah, but it's been shifted.
No, because
They can't still intersect at the same point.
What's the difference?
Oh, well, the bounds of the
It's
y.
the top.
Wait,
What's the difference between the top and the
I feel like they'd be the same.
I feel like that is weird.
That's why I think it's 0 to 2 plus root 2.
Wait, no, so we're right here.
2 times root 2
This way.
plus.
No,
Isn't that 0 to
it'd be 0 to
Is
2
it 0
minus
to 2?
root 2?
Or
No.
is it 0 to 2?
Is it 0 to 4?
Well, 0 to 2 is here, right?
Isn't that 0 to
So it can't be 0 to 2, because there's a hole here, so it's 0 to, oh, maybe.
I said that.
Well, when Marcus is maybe, he literally just means maybe.
I probably wrong.
But no.
Doesn't make any sense, it's the
I
formula.
think we, didn't hear you say that?
That makes sense.
Don't worry about it.
The volume. We're finding the volume
How
also
come
that this
that's
curve
the
is
whole
producing.
thing, and then on that one, it's
This
0 to root 2
rotation
rather
curve is
than negative
producing
root 2 to root 2?
solid that has this shape.
Yeah.
Curve on the inside, straight on the outside. We're looking for that
We're going on
solid.
the y.
And I'm gonna integrate over some x bounds. So does it make sense that I'm integrating from here to here, or do I integrate from here to?
Well, that's because on the first one you just did the.
Why did I just do, on the first one, why did I just do root 2 here? What did I just do that for?
Because.
Hey, that was a y.
Because that's where they.
Or
That's where they
How
intersect.
far out did this function go? Where would it cross the x-axis at?
Root 2.
At root 2,
Yeah.
right? So we went from 0 to root 2. If I
Oh,
was doing
so-
Well,
along
why
the
did we start
y's,
at 0?
if I was doing along the y's, I'd have gone from here to here and integrating it from negative something to positive
Oh,
something,
oh.
which would have been 2,
Mhm.
0 to some positive a, whatever that value is. By the way, we know what it is.
Looks like D. Is it D?
Root 2.
From here to here,
Root 2.
how far up did I go?
Isn't that intersection point?
1.
you put in root 2 as x.
1.
If I put in root
2x,
2
it'd be
is
2
x, I get
root
2
2.
root 2. So I go from 0 to 2 root 2. So along the y, so along the x though, it intersected at the x there, so that's where I stopped it. So over here, logically then, it would be from,
0 to 4.
yeah, set it up and go.
It's on the x.
And it's on the x. That's the Washer method. The general form is, ching, and I just find the big R's and little r's, put them in and go at it. Okay? I think I'm done. That's kind of crazy. Yes, ma'am?
So,
New
this is
record.
a little bit off, but so the quiz on Friday, will it also cover this?
No.
Okay, so just like through the, was it?
5 and 7.
Sorry?
5 and 7.
Section.
So like no integration between, like even for the area between curves.
Well,
that's
chapter
chapter
5,
six.
did we do anything in
that-
chapter 5
I think
like
No.
that? No, we just
No.
did area
Seven
under
dash.
curves in
Okay.
chapter 5. A little bit of chapter 7 would have been U substitution, no, not
Okay.
U substitution,
Integration
integration by
by
parts or fractional decomposition, some of those basics, right?
Oh.
They could appear.
So was this here, the part, the trig, like,
The trig
We didn't do
identity
any of that.
stuff. We did a little bit of trig stuff where we had secant or sine squared and cosine to the fifth. We had some properties there. I won't put that on the assessment this week.
Alright.
Cause section 7, or
I
chapter
might
7
should
covers a
have
lot of
here on the
weird
AP.
stuff.
Huh?
Chapter 7 covers a lot of weird stuff.
Yeah, we just, as I said, the two major components, right?
Yeah.
Yeah.
Fraction decomposition
Integration
and
by parts.
integration by parts,
And then
those
it-
two.
And then
It's
chapter
multiple
5 is all
choice.
just regular.
It's just regular area under a curve stuff.
Well,
It's
there's
multiple
use substitution
choice.
practice. Is that 5 or is that?
That's chapter 5. Use substitution is chapter 5.
Oh boy.
And that's the chain rule, right?
Yeah.
Yes.
I agree.
I'm doing the change.
Product rule is integration by parts.
And then it'll be multiple choice again.
And, should I do multiple choice again?
You said you were going to.
Yeah.
I think the response
Can we
is
do
fine
both?
way to go.
I don't know.
We could.
No, we should practice multiple choice, cause we've been getting better. And the point of these.
I have been getting better, but it's not as good as I'd like to be.
Okay, I'll do both.
Is that better?
5 multiple
Why
choice
is-
and 1 free response.
No.
Or 10 multiple choice.
But I
and
want
one
to get
free
stabbed in the foot or
Something
my
like that.
hand, not both.
And the multiple choice will be no